All right. Okay, Sally. So for our first lesson, we're going to make sure that we're looking at a periodic table. So make sure you have a periodic table handy. Okay. And then I'm going to go over conversion problems, and those are 1A, K, and T. In order to be able to do these three problems, you need to remember this little chart that I had taught you where moles was in the middle. I don't know if you remember that, but moles is in the middle. And so moles is like a connecting unit. That's why moles are so important in chemistry. And so if you are trying to convert to particles, particles are going to be either any of these four things. Particles can be atoms, ions, molecules, or formula units. We'll talk about that when we're doing these three problems. So Avogadro's number, okay? So to go from moles to any of these four types of particles, or from these four types of particles to moles, you have to use Avogadro's number, which I'm pretty sure you know is this. And remember this conversion factor, you're going to be able to use this 6.02 times 10 to the 23rd particles equals 1 mole, no matter what you're talking about. So again, we're talking about particles, atoms, ions, molecules, formula units. Make sure that you understand that those are all types of particles and that you would use Avogadro's number to do conversions to moles. Now, over here on the other side, we have mass in grams. So in order to go from moles to grams or grams to moles, you use the molar mass. So that's why we needed the periodic table. So remember, molar mass is the decimal number from the periodic table. And I like to round to whole numbers. I don't know if your teacher does or not, but that's what I'm going to do. We're still going to be able to get pretty much the same answer. Okay, so that is a general overview of how to do these three problems that we're about to do. Okay, this is what you need to know to be able to do these three problems. Okay, so let's get started. So for number one, it says that it's asking you to start with 0.465 moles of CO2. So you're at moles, and it's asking you to find out how many molecules. So again, you're starting at moles, and it's asking you to find molecules. So if you look at your diagram, you're starting at moles, and it's asking you to find molecules, which are particles. So that means you're using Avogadro's number. Okay? So what I do is I take that value that you're trying to convert, the 0.465 moles of CO2. See, I wrote that down right there. And then I make a T-chart to make my conversion. Some people just like say multiply by or whatever. I like to do a T-chart. That way in here, I know I'm going to put my conversion factor. And so again, if I'm going from moles to molecules, that means I'm using Avogadro's number. So here's the conversion factor, right? We just talked about that. So I'm going to put the mole, the 1 mole on the bottom so that the moles cancel. And I'm going to put Avogadro's number of particles. And remember, particles can be any of those four things that I mentioned: atoms, ions, molecules, and formula units, okay? So the moles are going to cancel. Moles on top, moles on bottom. I'm going to multiply these two numbers because they're both in the numerator, and I get this answer in my calculator. 2.80 times 10 to the 23rd. MC is, for me, short for molecules. And so that would be letter B. Okay? So that's 1A. Okay, 1K. I'm going to skip 1K for a second. I'm going to go to 1T. Okay, 1T. The reason I'm going to 1T is because it is also a one-step, just like the one we just did. This one's a little tiny bit more complicated, so we're going to talk about a couple things. Okay, so first of all, this time it's asking you to start with moles, and it's asking you to find the grams. So moles to grams. So again, go back to your little diagram over here. Moles to grams. So I'm on this side, I'm using molar mass. That means I need a periodic table. I need a periodic table to find out the molar mass of potassium sulfide. Okay, so this is where it gets a little tricky. I hope you already know these things. If not, I'll be going over them in another video. Potassium is in group 1, so it has a +1 charge. You should know that already. Again, I'll go over it in another video. Right here. Potassium is in group 1, so it gets a +1 charge. And for sulfur, or sulfide, I should say, it's sulfide, which means it's the element sulfur, S. Okay? So where's S? S is over here in group number 6. It says 16, but it's 6. Again, I'll talk about that in another video. And so the charge of those elements are -2. So you should know that. You should know that K is +1 and S is -2. Well, the charges need to cancel. They don't. So you're going to need 2 of the potassiums. You're going to need 2 Ks for 1 S. That's how I got K2S. So potassium sulfide is K2S. Okay? Now, what we need to do is we need to find the molar mass of that. So that's, again, why you need the periodic table. So you need to add up the mass of 2 Ks and 1 S. So mine's a little blurry, but you should be able to see on a periodic table that K is 39 and S is 32. Those are the decimal numbers. So you would add 39 plus 39 plus 32, right? So one more time, because there's 2 Ks and 1 S, you would add up 39 plus 39 plus 32, which gives you 110. So when I set up my conversion, just like I did in that first problem, I start with the value they gave me, 3.25 moles of K2S. I do a T-chart. I'm going to put my conversion factor here. This time my conversion factor is the molar mass that I got from the periodic table by adding up the decimal numbers. So I got 110. 110 grams. Every time you add up the molar mass from the periodic table, it's grams, okay? And that's the amount of grams in 1 mole. So I set it up this way, again, so that the moles cancel. And the answer is going to be in grams, because that's what the question asks for. So I'm going to multiply these two numbers because they're both in the numerator. 3.25 times 110, and I get 357.5. When I look at my options, the only option that matches is letter D. Okay, I'm going to go back now to letter K. So the thing with letter K is, I want you to check something out. I want you to see that with letter K, you're starting with molecules, which are what? Particles. And the question is asking to find the mass. And you need to know that when they're asking for the mass, they're asking for grams. So right here, look, I'm looking at my options right away. I'm like, they're asking for mass, not moles. I'm going to cross out A and I'm going to cross out B. Right away, I know that both of these are not the right answer because mass is grams, which means we have to use the periodic table to get the molar mass. So one more time, where are we starting? We're starting at molecules, you know, a type of particle. And the question is asking for mass and the units are grams. So if I go back to my diagram, check this out. I'm starting way over here at molecules, and I need to go to moles, and then from moles, I need to go to grams. And what that means is that it's going to take 2 conversions. I'm going to have to use Avogadro's number and the molar mass. I have to use both of them in the same problem. Okay? So when I set this one up, I'm going to start with the 1.65 times 10 to the 25th molecules right here. See? MC for molecules. But I already know those are particles, which means I have to use Avogadro's number. So my next conversion factor to cancel out those molecules is to use Avogadro's number. Notice that this time I put Avogadro's number on the bottom because I need the molecules to cancel. Yes? And now I'm at moles. So what I just did, I just went from here. I went from particles to moles using Avogadro's number. So I'm right here. But I need to go here because that's what the question asks for. So I need a second conversion factor. So you see how I set it up so that I have a second conversion factor, which is the molar mass. Remember we talked about that? We're going to need to find the molar mass. Of what? Of oxygen gas. So here's another little thing that you need to know, and I'm sure your teacher already taught you. Oxygen gas is one of the elements that exists as a pair that's called diatomic. So it's O2. Oxygen gas is not just O, it's O2. Because it's a diatomic molecule, it always exists as a pair. So it's going to be O2. Your teacher might have taught you to remember them as Brinkelhoff. Brinkelhoff. Okay, that might be one way your teacher taught you. Brin, chlorine, hydrogen, oxygen, and fluorine. All these 7 elements exist as pairs. So it's Br2, I2, N2, Cl2, H2, O2, F2. So that's why we're talking about O2 here. So to get the molar mass of oxygen gas, you have to add up 2 O's. So that's why, you look at the periodic table, oxygen is 16, right? 16 plus 16 is 32. So from the periodic table, the molar mass of O2 is 32 grams. So when I set it up, there are 32 grams of O2 in 1 mole of O2. Yeah? And why did I set it up that way? Because look, I need the moles to cancel. Now, when I plug this in my calculator, I'm going to put 1.65 times 10 to the 25th power divided by Avogadro's number. Because it's in the denominator, you have to divide. Then you're going to multiply by 32. What does that give me? 877. 877. 877 grams. Okay, make sure you remember that. That's why it's asking about the mass. 877 grams. So that's why the answer is letter D. Okay, that was lesson number 1.